Hello everyone, I hope everyone is safe inside. I, Anirudh Dinesh Bagle, welcomes you all in our presentation. The topic of our presentation is one of the most important topic in the future, technology, that's wireless and optical communication. I would like to introduce my two teammates that are Deep Vasadekar, Shreyas Patil, Shubham Sardeshai, Abhishek Wagh and I, Anirudh Dinesh Bagle. The project is completed under the guidance of Dr. Mahesh Shinde sir. So let's see the preview of our presentation that are introduction of wireless and optical communication, history of wireless and optical communication, the revolution of wireless communication, and the types of optical fiber communication and their applications. The other we will see that choice of wavelength, category of implementation, device and standards, wireless security, implementing network inclination and others. We know communication is traveling of some information from one part to another part. That's communication system is of two types, wired and wireless communication. In wired communication, the medium is required, the physical medium is required. It can be coaxial cables, twisted pair cables, optical fiber links, etc. On the other hand, wireless communication doesn't require any physical medium but propagates signals through the space. In this topic, we will see only on wireless communication. Wireless communication is the fastest growing and most vibrant technology areas in the communication. Wireless communication is a method of transmitting information from one point to another without using any connection like wire, cables or physical medium. We live in the world of communication and wireless communication we use many systems in day-to-day life that are mobile phone, remote controls, Bluetooth audios, and Wi-Fi, etc. Optical communication. Optical communication is came from fiber optical communication. The fiber opticals. We live in the world of communication and wireless communication. Actually, it becomes a part of our life. We see many wireless devices in day-to-day life, that is mobile phone, GPS receiver, remote controls, Bluetooth audios, and Wi-Fi, etc. Now, optical fiber communication. What is optical fiber communication? Optical fiber is a type of fiber which uses lights to transfer the information. It is based on the principle of TRI, total internal reflection. Now the question arises, why we should use wireless communication? When wired communication can do most of the tasks that a wireless communication, then why should we need to wireless communication? The main answer can be easy, flexible and mobility of the wireless communication. In our daily life, it is easier to use wireless things like mobile phone and Wi-Fi network. In old days, we were using telephones which have a long cable wires. It is very difficult to use that, so it's easier and convenient to our day-to-day life. The further part will be explained by my colleague.
So why wireless communication? When wired communication can do most of the tasks a wireless communication can, why we need wireless communication? The primary and important benefit of wireless communication is mobility. It is that we can move from one place to another without any wires. Apart from mobility, wireless communication also offers flexibility and ease of use, which makes it increasing popular day by day. Wireless communication, like mobile telephony, can made anywhere and anytime with a considerably high thoughtful performance. Means it is useful for long distances. History. Wireless communication technology proliferated and became essential very quickly during the few decades of 20th century and early 21st century. Optical wireless communication (OWC) refers to the transmission in unguided propagation media through the use of optical carriers, visible infrared IR and ultraviolet UV radiation signaling through beacon fires, smoke, ship flags, and semaphore telegraph can be considered the historical forms of OWC. Means these are the various types of optical wireless communication. Sunlight has also been used for long distance signaling since very early times. Means with the help of sunlight due to reflection we were used for signaling very early. So, timeline 1896 first practical wireless telegraphy system based on radios. 1900 first television displayed only black and white images. Over the next decades, color television were invented, showing images that were clearer and in full color. 1914, first North America transcontinental telephone calling. 1927, television. 1927, first commercial radio telephone service in UK and US. 1930, first experimental video phones. 1934, first commercial radio telephone services, US, Japan. 1936, world's first public video phone network. 1946, limited capacity mobile telephone services for automobiles. 1947, first working transistor. 1950, semiconductor era begins. 1956, transatlantic telephone cables. 1959, metal oxide semiconductor field effect transistor, also known as MOSFET. 1962, commercial telecommunication satellite. 1964, optical fiber optical telecommunication. 1965, first North American public video phone network. 1969, computer networking. 1972, discrete cosine transform DCT, digital media data compression. 1973, first modern era mobile cellular phone. 1974, internet. 1979, Inmarsat ship to shore satellite communication. 1981, first mobile cellular network phone. 1982, SMTP email. 1998, mobile satellite handheld phones. 2003, VoIP means voice over internet protocol, internet telephony. These were the small and small development in the optical fiber communication. Photophone. The photophone, originally given an alternate name of radiophone, it is a communication device which allows for a transmission of a speech on a beam of light. Means the voice can be transferred with the help of a beam of light. It was invented jointly by Alexander Graham Bell and his assistant Charles Schumann Trenter on February 1880 at Bell 1325 L Street Laboratory in Washington, D.C. Both were later become full associate in the Volta Laboratory. Association created and financed by Bell. The photophone was precursor to the optical fiber communication system, which were achieved popular worldwide usage in 1980s. The master patent of the photophone means these are the master patents. US patent 235,199 apparatus for signaling and communicating called photophone was issued in December 1880, many before its principle to have practical application. Thank you.
Hi everyone, my name is Shreyas Sunil Patil. I am here to explain electric wireless technology. In early 18 BC, we can transmit electrical signals and data up to a 10 kilometers on a ground using electrostatic and electromagnetic induction, and in water we can transmit data up to a 30 kilometers. In 19th century, before a practical radio system became available, these include a patented induction system by a Thomas Edison allowing a telegraph on a running train to connect with a telegraph wires and running with parallel to a tracks. Radio wave. After the proof of existence of radio wave in 1888 by Heinrich Hertz, the Galileo Marconi started developing a wireless telegraph in 1984 using radio waves. Marconi developed the longest transmission system which were known at that time. Marconi soon developed a system that was transmitting signals beyond a distance anyone could have predicted. It is happened because the signals are bouncing back from the ionosphere. Marconi and Carl Fredson were awarded the 1909 Nobel Prize for the physics for the for their contribution to the form of a wireless telegram. Evolution of a wireless technology. evolution of wireless technology is start from 1873. It's going till now. Nowadays, the evolution of a wireless technology is growing in wider areas and wide way, like nanoparticles and fiber optics, etc. The first radio is invented in a 1906. First telephone is invented in a 73. First TV is invented in a 63. First Bluetooth is invented in 2000. First smartphone is invented in 2007, and etc. We can refer above chart. Wireless evolution. The wireless evolution is began in 1990s. It also known as a social revolution of a wireless technology. It includes the cell phone, mobile, telephones, pagers, internet, wireless internet, etc. The wireless revolution has been driven by the advanced radio frequency area, microwave engineering, and the transmission from the analog to digital RF technology, which enable a substantial increase in a voice trafficking along with the delivery of a digital data such as a text, message, image, and a streaming media.
Free space optical. Free space optical communication is also known as FSO. It is the optical communication technology that uses light propagating in a free space to transmit wirelessly data for telecommunication or computer networking. Means it is the technology which is used for a telecommunication of data wirelessly with help of light propagating in a free space. The free space means the light beam travel through the open air or the outer space, means the space outside the earth or in the air. This contrasts with the other communication technology that uses light beams traveling through transmission lines such as optical fiber. Means it is another than the optical fiber because it does not use the transmission lines to pass their message. Indoor wireless optical communication. Indoor wireless optical communication links provides a flexible interconnection within a building where setting up a physical wired connection is cumbersome. Means it is the communication of where the physical connection is difficult to make. It consists of lasers or a light emitting diodes, means LEDs, as a transmitter and photodetectors as a receiver. In the indoor WC is inherently secure technology since optical signals do not penetrate walls unlike electromagnetic waves which can cause interference and thus provides a high degree of security against eavesdropping. Means it is not like electromagnetic waves which cause interference and which are very less secure. These optical waves are either in a visible light spectrum or in a infrared means IR spectrum, which is able to provide a very large bandwidth. Since these devices consume very little power, they are also suitable for mobile devices. Outdoor wireless optical communication. Free space optical communication requires a line of sight connection between transmitter and a receiver for propagation of information from one point to another. The outdoor wireless optical communication is also known as a free space optical communication. It is used the line of sight connection between transmitter and receiver, means there is a connection which can see the receiver and sender directly. Here the information signals from this source is modulated on an optical carrier and this modulated signal is then allowed to propagate through the atmospheric channel or a free space. Here these links are combination of terrestrial and space links because they both involve the propagation through ground as well as through the satellites. Wireless security. The various wireless security protocols were developed to protect home wireless networks. In the wireless security, there are various protocols. They are named as WEP, WPA, and WPA2. Each with their own strength and weakness, means everyone has their strength as well as their weaknesses. In addition to preventing uninvited guests from connecting to the wireless network, this wireless protocols also serves to encrypt our private data as being transmitted over the.
Good morning, friends. I am here to discuss what my friend has already told us, wireless security. So, the wireless security consists of the following: WEP, WPA, and WPA2. So, WEP stands for Wired Equivalent Privacy, WPA stands for Wi Fi Protected Access, and WPA2 stands for Wi Fi Protected Access 2. The original encryption protocol developed for wireless network is WEP. So why was WEP developed? WEP was developed to provide the same level of security as wired networks provide us. However, WEP has many flaws. It's difficult to configure out it, and is it can be easily, means anyone can intervene easily through WEP. It can be easily broken. So WPA, Wi-Fi Protected Access. It was introduced as an interim enhancement over WEP, while the 802.11i wireless security standard was being developed. Most current WPA implementations use a pre-shared key, commonly referred to as WPA personal, NAD the temporal key, integrity protocol TKIP. For encryption, WPA enterprises use an authentication server to generate keys or certificates. Wi-Fi protected access 2. Based on the same 802.11i wireless security standards, which was finalized in 2004. The most significant enhancement to WPA2 over WPA is the use of advanced encryption standards. So the encryption, what does encryption mean, is going to be explained in the next slide, but for the current understanding, for time being, just remember advanced encryption standards. The security provided by AES is sufficient for use by the US government to encrypt information classified as top secrets, isn't it? So encryption is required to secure our data. So what is encryption? Encryption is a reversible transformation. Encryption, by the way, it is locking a data, and only two people have the key of that locked data, the sender and the receiver. When the sender sends the data, he locks it and sends to the receiver so that no other person can intervene into that data. And receiver, when receives, has the key, he unlocks the data and he can read the data what is given to him. So some scientific terms used here. The reversal process is called decryption. It's when the sender is encrypting the data and the receiver is decrypting the data. So sender sends the means locks the plain text, encrypts the plain text, and the plain text is decrypted by the receiver. So each encryption and decryption functions requires a cryptographic key. I told you key, the scientific term used is cryptographic key. Is a string of binary digits used as an input to encryption and decryption functions. So the main conclusion, wireless communications. Wireless communication enables us to contact anyone anywhere in the whole world. It has made world a small market we can go anywhere and we can contact anywhere, we can communicate with anyone. Mobile phones and tablets are doing our work very very easy. Means you can just order, if you want something we can order it online nowadays. If you want to call anyone in any part of the world, you can just contact with telephone or mobile phones. Then in rural and poor areas also, to have the communication tools, they need to improve their life. It helps them to improve their life. Thank you very much.